Hello, I'm Jenny Grosslight with Keysight Technologies. This video covers protocol solutions for ONFi 5.1 using the U4164A logic analysis system for capturing DQ over 1600 megatransfers per second data rates. In this video, we will cover an overview and background of the need for the higher speed DQ capture solution. Probing method number 1 using STpro footprints designed into the validation platforms. Probing method 2, custom interposers, and we'll look at the differences in the current ONFi timing only solution and the new timing state solution. We'll wrap up with a summary. Since ONFi commands transition asynchronously at rather slow speeds, timing mode is more than adequate to capture all signals required for protocol analysis, even at the higher ONFi 5.1 data rates. The licensed software option, B4661A-4, either TP-FP or -4NP for the different license types, provides transaction decode, timeline, traffic, and details for different views of the ONFi protocol. Watch for another video with more details on the ONFi memory protocol tools. As an overview, the background behind why we need another solution to cover ONFi DQ commands over 1600 megatransfers per second. It's due to a lack of a common clock for both the ONFi commands and DQ. That means that traditional ONFi solutions use timing mode on the logic analyzer. ONFi commands operate at slower speeds even when the DQ rates increase. However, the accuracy of DQ capture over 1600 megatransfers per second begins to degrade using timing mode due to the channel-to-channel skew and sample resolution. What is noticed by users is that the bit error rate on DQ increases when the speed increases over 1600 megatransfers per second. The solution to capturing DQ over 1600 megatransfers per second for ONFi is to continue to capture the command using timing mode with one U4164A module. The commands for decoding multiple ONFi channels can be sampled using a single U4164A module. For each ONFi channel, a separate module in quad sampling state mode is required to capture all the DQ using the DQS as the logic analyzer clock. The solution for DQ over 1600 megatransfers per second requires at a minimum that all DQ are double probed. The U4164A with option O2G can capture up to 4 gigatransfers per second in state mode. This solution covers all ONFi data rates in the 5.1 version specification that was released in August of 22. Currently, the solution requires that the user controls read-write traffic during the tuning of the read-write sample positions. After tuning, read and write can be interspersed. Two viable probing methods for capturing ONFi protocol and DQ over 1600 megatransfers per second are using a STpro footprint designed into the validation platforms or use custom interposers. Probing method number 1 for capturing over 1600 megatransfers per second ONFi is to design in the STpro footprint to your board. STpro footprints will be located between the controller and memory. STpro is proven to 4 gigatransfers per second. 2 separate U4164A modules are required for one ONFi channel. 3 modules will be required for 2 channels. For a single ONFi channel, one module will be in timing mode to capture the command control signals from one or more ONFi channels, and one module is required to capture DQ from each channel in state mode using DQS as the clock to the logic analyzer. DQS, DQ, and possibly some control will be double probed. DQS is the clock into the U4164A module. Double probing is used to route one set of the ONFi signals into the timing analyzer for capture of the protocol, and another set of ONFi signals is routed into the state analyzer for DQ capture. There are 2 methods to double probe. The first one is to use the Future Plus FS1300 ONFi Direct Connect cable that will do the double probing for you from one STpro footprint. Another method would be to connect the U4164A modules using two STpro footprints, so more real estate on your board, and two U4206A probe cables. This slide is an overview of the ONFi solution for over 1600 megatransfers per second using one STpro footprint for two ONFi channels with the FS1300 probe cable solution. The minimum solution for one ONFi channel requires two separate U4164A modules. A single STpro footprint accommodates two ONFi channels. When you're routing the channels to the footprint, all signals for one channel should go to the upper half of the footprint, with the DQS differential signals coming into the differential clock inputs for the upper half. And then the second channel should all be routed to the bottom half of the footprint, and the DQS for that channel should come into the differential clock inputs for the bottom half. For a single channel, one module will be in half-channel timing mode to capture the slower command and control signals. And note that one module can actually handle up to 4 channels of ONFi command control. From the footprint, the odd pod will be bringing the signals for one channel into the logic analyzer into one pod pair. And the second channel, if you have 2 channels routed, can also be brought into a pod pair on that same timing analyzer. For a single channel, one quad sample state mode module is required per ONFi channel. And this is to capture the DQS and DQ. DQS for the channel is the clock into the logic analyzer. The FS1300 Direct Connect probe double probes every signal. It will bring one set into the timing analyzer, so one channel, one pod pair, but if you have both channels routed, you'll have the even and the odd connected. Then it also routes out 4 pods, routing the signals for quad sample state mode to the 4 pod pairs. And this is actually routed into only pod 1, pod 3, and then it says pod 5 and 7. Pod 1 and 3 will have the signals for the top channel, and pod 5 and 7 would have the signals for the bottom channel. So into one state mode logic analyzer, you will have 2 pod pairs off of the FS1300. And then if you had a second channel, you'd use the other 2 pod pairs, 5 and 7, would go into a second state mode logic analyzer in the quad sample state mode. Each STpro footprint can handle 2 ONFi channels. DQS must be routed into the differential clock. Route all signals for one ONFi channel to the upper half, and route all signals for the second channel into the bottom half of the connector. Do not mix the channels up on the connector. When you're designing with the STpro probing, the best practice is to use flow-through routing, where the traces are routed through the STpro pads. This eliminates stubs and maintains constant separation between the traces in differential pairs. Keep the stubs from any inner layers or pads using vias to a minimum in number, and especially minimize their length. Stubs increase the loading and reflections, resulting in degraded eyes to the U4164A, and they create disturbances to the system under test. It's not always possible to route all signals using flow-through routing. Make sure you keep stubs to a minimum. For the configurations, Keysight can assist in creating configurations on validation platforms or for custom interposers. Keysight has a DDR ONFi configuration creator tool that makes configurations for unique footprints. Timing mode U4164A modules can be the base module speed with no additional options required. State mode U4164A modules must each have option U4164A-02G for the 4 gigatransfers per second data rate capture and the required quad sampling. In quad sampling, the 4 samples captured per clock edge are read DQ rising, read DQ falling, write DQ rising, and write DQ falling. This is a STpro load model for a single U4206A. For single-ended probing simulations, ground one input. This is the differential model. It is modeling the pads on the board and the tip RC of the logic analyzer that's at the spring tip in the cable. There is a 0.35 picofarad and 20 k ohm resistor at each probe tip. This is the double touch load model. You'd have a single set of soft touch probe footprint pads, and then the tip RC into the logic analyzer with the rest of the input of the logic analyzer modeled as a 75 ohm transmission line into 750 millivolts. You run the simulation at the point of the tip RC network, which is at the pad of the soft touch probe. For probing method number 2, Keysight does offer custom interposer design. Typically, these are installed under the memory. They're specific to a memory package. They come with a riser to help get around surrounding components. The interposer contains a damping resistor to isolate the system under test from the logic analyzer cabling. And for the higher data rate designs, they include the RC probe tip network for the logic analyzer on the interposer. This is to remove bandwidth limitations by minimizing the trace length between the tip R and the RC network. Most interposers with the RC networks are proven 4 gigatransfers per second. Depending on the design, they might have a ZIF cable or a soft touch pro cable that connects the logic analyzer to the interposer. The photo here is an example of an LPDDR4 interposer that has the tip R and RC network around the memory on the top of the interposer. Interposers are installed on the PC board with a riser to provide clearance for surrounding components. Then the interposer is on top of the riser and the memory device on top of the interposer. For probing method number 2 with the custom interposers, these are extremely challenging to design. Designs for over 2 giga sample per second, where you would need the RC probe tip network, are particularly challenging. Flow-through routing isn't possible for interposer designs. Designers must minimize the stub length when routing traces out of the package to the tip R. Signals after the tip RC are particularly vulnerable and require a controlled 75 ohm transmission line into the logic analyzer. Keysight does not provide documentation or support for users to design their own interposers. Keysight does offer a custom interposer design program. You can contact your Keysight representative for details. The main differences between the timing-only and timing state solutions. For the timing-only solution, the maximum DQ data rate capture will be 1600 megatransfers per second, whereas the timing and state solution can cover data rates all the way up to 4 gigatransfers per second. The timing-only solution does not require double probing. The timing and state solution does. The number of modules and cables required to cover one ONFi channel. For the timing-only solution, to get address, command, and data up to 1600, you will require one U4164A module with option O2G speed grade and one U4264A cable. For the timing and state solution, all of the protocol at ONFi 5.1 speeds and DQ up to 4,000 megatransfers per second, you will require quantity 2 U4164A modules, one module with option O2G and the other module with the base speed option. You'll require one FS1300 cable. How many modules and cables are required to cover 2 ONFi channels? For the protocol-only solution, the configuration is the same for 1 or 2 channels. For the timing and state solution, you will require 3 modules. 2 of those will need the option O2G speed option, and 1 can be in the base speed option to capture the command and address. In summary, Keysight has a solution for ONFi data capture over 1600 megatransfers per second. Thank you for your attention.